In this example of compound interest question, we're looking at finding the multiplier. The multiplier is the unknown. The question reads, Naomi invests £6,000 for 5 years. So we actually know that £6,000, what they're investing is the original amount. So I'll just go and annotate that. This is my original. 5 years, so N is 5. The investment gets a compound interest of X%. So this is percentage is unknown. So if we don't know what the compound interest is, we won't actually be able to work out the multiplier. So this multiplier, whatever that may be, is unknown. And that's what we're trying to work out. Now it says here, at the end of the 5 years, the investment is worth £8,029.35. So this here is my new amount. So if I then go to my equation, I can write down all the things that I know. So I know it says work out the value of X, but I'm going to just simply go to my formula here. Original is equal to multiplier to the power of N years is equal to new. So I'm going to write down what we know. Original is 6,000 times multiplier, which we don't know. So I'm going to leave it as multiplier, or M in this case, to the power of years, which I know. I'll write down multiplier here. To the power of N, which is 5 years, is equal to the new amount, which I know is £8,029.35. I want to work out what my multiplier is first before I can work out the X percentage. So don't worry about the X for the time being. So let's divide both sides by 6,000 to do the inverse of the times 6,000. So dividing both sides by 6,000 leaves me with multiplier to the power of 5 is equal to 8029.35 over 6,000. Now then, to get rid of the power of 5, I need to do the inverse of power of 5, which is to do the fifth root of it. So if I do the fifth root of both sides, I'll be then left with fifth root of 8029.35 over 6,000 on the right hand side, and on the left hand side I'm left with the multiplier. So I can then go on to type this into my calculator, the value of this. So here I've got 8029.35, and I'm dividing that by 6,000, and then I'm doing the fifth root of that answer. So that gets me 1.05999 recurring. I'll just leave it to a few decimal places here. It goes to 999, then it goes to 9999908. I'll write down the full display on my calculator. I won't round at this stage, otherwise I'll have rounding inaccuracies here. So I'll just leave my full calculator display. Now, if this is my multiplier, know how I work out the multiplier by taking the percentage it's increased to or decreased to, and then dividing by 100. Now I'm doing the reverse to go from the multiplier to the percentage. So I'm going to do this number here, the multiplier, times by 100% to change it into a percentage. So when I times it by 100, I get 105.999908%. So from here, I can see how much it's actually increased by. Original amount is always 100%. So from 100% to get to 105.999908%, it's obviously increased by, I'll just write down now to 3 significant figures. It's increased by 5.99999908%, which then, if I round to 3 significant figures, is 6.00% is how much it's increased by. So increase of 6.0%. How did I work that out? All I did was 105.99999908 minus the 100% that we start off with originally. That's how I got that. So now I can go and answer the question. The question says the compound interest is X% per annum. Since I know what the increase of the multiplier was, I was able to work out this percentage interest that I'm getting. So I can then write down X is equal to 6%. That's what we were after, the percentage. So work out the multiplier first and then work out what the percentage increase or decrease may have been by looking at the difference from the original 100% to what our multiplier is as a percentage.